Java ambassador. People tell me that if I'm supposed to have the title ambassador, you should all call me Your Grace, Your Honor. I am not. So I'm sort of, people call me a lot of stuff, including ambassador, evangelist, architect, system engineer, whatever. When it all comes down to it, I write code. And I talk about it a lot to people like you. That's usually what I do. I like writing code, and I've been programming Java since the release of Java in 1995. I didn't work for Sun back then. I'm working for Sun almost 10 years now. And, well, nowadays I'm the official spokesperson on Java and software development matters and open source and environmental issues here in Sun Nordic. So not only is the stuff that I'm going to tell you tonight interesting, but it's also officially right? It's officially true, and that's sort of so you understand where I'm coming from. Everything I will tell you is officially true, and since I'm also into open source, environmental issues, and all that stuff, it's also the official good side here. So just to know that any criticism you might have for me today is actually evil, right? I want to talk to you a little bit about Java. I guess most of you program Java. How many of you program Java? Yes, you do. Right. How many of you like programming Java? Why? Oh, come on, why?
It's OOP.
Focus is OOP.
It's scalable and we can apply design patterns.
There you go. Good. Three good reasons right there.
Independent.
Sorry?
Platform independent.
Platform independent. Very good reason. I love that. Actually, that was the reason I did my first professional gig in Java, because they wanted me to write a Windows application, and I thought, nah, I don't want to do that. So I wrote it in Java instead, and no one noticed. It was great. More?
Libraries, frameworks.
Ooh, that's a good one. Actually, I would say that the planet's best libraries are on the Java platform. So we can all agree that Java is a great platform, right? The real problem is, of course, that Java is under constant attack from everyone else. And the big question is, of course, will Java survive? So what do you think? Will Java survive? How many of you think that Java will be here in 10 years' time? About half of you. That's a little bit discouraging, isn't it? Well, the rest of you, what do you think will happen? What will win over Java? What will push Java out of the market? Windows?
Market is already down, so how can I say that Java will survive? That you can do 10 years more. You know this financial crunch, no idea. So, it can be a possibility one side. I mean, I'm not saying that definitely Java will. I'm not saying that the Java will die in 10 years, but there will be a chance.
But you're saying that Microsoft has already won?
Yeah.
Maybe they change their business strategy to focus on a particular area, not focusing on each and every problem. Just like common in mobile games and telecom sector, but not much focusing on the bar. Right? So maybe the focus on some particular area, not in all domains.
All right. More views. Come on. I mean, I'm the official Java guy from Sun here, so you can say anything you want to me, and I have to take it back to my seniors as well, and to Jonathan Schwartz and who's ever in the Java campus. This guy. So come on.
I think it's going to survive because there are a lot of Java applications out there. If the company wants to change the program that they already had, it works. So why they have to change it?
True. Actually, you're touching on a really good point here, because I don't think that Java will go away in 10 years' time. Java will be here because there are 6 million Java programmers in the world. I mean, they won't unlearn Java over 10 years. We don't do that. I mean, people don't. People still program in COBOL and Fortran, for heaven's sake. And way past where they should have stopped programming in COBOL and Fortran, by the way. Or at least COBOL. Yes?
Is it only about surviving or it's about beating competition?
Well, that's the point. I think that Java will be here. The big question, of course, is will Java be here as anything else than an embarrassing legacy? Like COBOL. I mean, will we be laughing, snickering about Java programmers in 10 years' time, saying, yeah, right, fun. And to be honest, there's a very real risk that we actually will be. That will be snickering. And we'll be laughing at Java programmers going, oh yeah, I remember that. That's like Pascal today, right? Oh yeah, I know that you actually used to teach Pascal at this institution, but I'm still reserve my rights to sort of talk about it because I started out programming in Pascal. Well, that was my second language, after third language, fourth language. Anyway, in the 80s. Sorry.
Writing the Java will survive for 10 years because many partners like Oracle, IBM, and Google are supported for the Java.
But then again, IBM supports COBOL, and I mean, it doesn't really help COBOL as a surviving. Well, it probably has helped COBOL surviving at all because that's where we write COBOL programs now. But it can still be an embarrassing legacy, I think. The thing is, and what I'm sort of will try to show to you today is that it might very well be that Java might be an embarrassing legacy. The Java, the programming language, might be an embarrassing legacy in 10 years' time. But, or not an embarrassing legacy, but something that you sort of program in as an esoteric experience or exercise in doing low-level stuff. But the Java platform will survive. And if everything goes the way I think it should, and certainly the way some think it should, that will happen. Just as C is today. I mean, C is something that you use to write low-level stuff, hardware accessing stuff, or operating systems in general. And you don't use it for writing applications anymore. And I think that Java, the programming language, will probably be there, but the Java, the platform, I think will survive. Or at least I hope, otherwise I'll be out of a job in 10 years' time, and I will sort of be, well, might even be sooner, you never know. Alright, so, what will we have instead? What will the landscape look like? What will happen? What will happen with the Java platform? And that's what I'm sort of trying to sort of talk to you about today. We'll see if that works. First of all, as you saw, I wrote something, and I'm sort of going through this. I'll write my own PowerPoint presentation package using something called JavaFX. How many of you have heard of JavaFX? All right. Now you'll hear some more about it. All right. Let me just switch slides. This package is a little bit unsophisticated at the moment, but we'll improve it as this talk goes on. So what is this? This is what I wrote, apart from a truncated string over here. This is what I wrote. This is a new programming language that we've invented called JavaFX script. And it's part of the new JavaFX platform. It all sounds very cool and very sort of Hollywood, doesn't it? And there's a reason for that, because it's supposed to be very cool in Hollywood, or at least cool, or at least very. I think we'll settle for very. Actually, it's supposed to be very easy to write stuff in, and sort of that's at least I can show you that today. What we have here is a scripting language that is used to control the new JavaFX platform, and the new JavaFX platform is a platform for what is usually called, which is a very suspicious term, I admit, but it's usually for rich internet applications. And of course, rich internet applications is a very unfortunate term because, I mean, is there any application out there that doesn't use internet in some way? And what difference is rich internet application from any other application? But there you go. What it is in reality is something that is supposed to meet the threat of Silverlight from Microsoft and Flash and Air from Adobe, and that's it. So we're going head to head with Flash and Silverlight, which is a little bit scary, I can tell you. But we'll try to do it anyway and see what happens. The thing with JavaFX is that, well, JavaFX was founded on one specific question, or actually 5 questions, but let's take them one at a time. And the first question is, why is it so hard to write GUI applications when it's so easy to write web applications? Because if you look at the web application, it's a distributed application. You have a client somewhere just on the other side of the internet. You have vaguely specified markup languages and HTML and cascading style sheets. You have trying to maintain state over a stateless connection, HTTP, and a lot of stuff like that. And regardless of that, we get it all right? Oh, most of the time, or some of the time, anytime. Anyways, so I mean, and we can write web applications. I can write web applications application in 2 minutes flat, but I surely can't write a Swing application in 2 minutes flat. How many of you have written Swing applications? How many of you think that writing Swing applications is fun? Yeah, thought as much. Few in front here, no one raised their hand. So just you know. All right. So that was the fundamental question, and of course, the answer to that question is quite simple, because HTML is a declarative language. We don't say table equals new table and then table.row dot add row equals and so forth. You see what I mean? We don't do that in HTML. We suggest, well, here's a table and here are the rows and here are the cells and there you go. So Chris Oliver, who works for our research department, Sun Labs, he thought, well, could we do the same thing for GUI applications, for Swing applications, maybe? So that's the first thing he said. So he thought, so could we have a declarative language? So he came up with JavaFX script. Well, it wasn't called JavaFX script back then. It was called form follows function, which was a weird name. So someone changed it to JavaFX script, which is an even weirder name, I guess. And also not to be confused with JavaScript. And now someone at our marketing department should probably be short. So it's JavaFX script, but never mind that. This is JavaFX. Well, do mind JavaFX script, because I'll get back to why you'll there's a reason for that. Apart from our marketing department being all drunk all the time or something like that. Anyway, so JavaFX script is a declarative language, and so what you do is that you just declare stuff. So we have some import stuff, never mind that, it's just exactly the same as in Java. And then we have a stage. And the stage in a JavaFX application is one of the other things that sort of differs JavaFX from the rest of Java, because that comes down to the second question he asked himself: why are Java applications or GUI applications in general so ugly? How do they avoid the gray rectangles pattern that we have in typical GUI applications? Because if you look at it, as he says himself, if you look at Flash applications, it's not gray rectangles, but if you look at the Swing application, the Windows application, and from time to time even a Mac OS X application, or Cocoa application, it's just a mass of gray rectangles. And it doesn't really look that good, right? So the next thing he thought was, well, what happens when we build an application? Typical scenario on a professional level when we build an application. Well, we take a graphical designer, maybe a designer with some expertise in UI design, and they come up with a prototype, which they do in what? Photoshop. And then a couple of programmers or a bunch of engineers are keeping themselves busy for a couple of months, transforming this beautiful mock-up done in Photoshop to a mass of grey rectangles. And of course destroys everything that was ever beautiful about that application. So, but in Flash, we don't do that. In Flash, the GUI designer or the graphical designer does the markup in Photoshop or whatever, and we import it into Flash and just use the same graphics, and everything looks nice. So, couldn't we do the same? Well, we actually can, because Java has support for it. The Java 2D package, which is, among other things, used for rendering Swing, contains everything that you'll ever need, mostly at least, for doing beautiful graphical user interfaces and beautiful graphical work, because it has all the primitive it has all the graphic primitives that you like, including things like filters and shadows and opacity and all that stuff. So let's just choose that then. So this is what JavaFX, the JavaFX rendering model is based on. JavaFX rendering model is based on a stage where we do our stuff, and then we have widgets, which is just sort of Java 2D elements that are drawn upon that stage. Or, as a matter of fact, it's drawn in a scene graph. So if you ever try to handle game programming, you'll recognize the scene graph as a core element of game programming. You build your scene graph, and then you hand that over to whatever rendering hardware you have, and do the rendering on let that do the rendering on the scene graph. And it's exactly the same here. And on a Java 6 JVM, you'll actually get this rendered by the rendering hardware on your computer. So we have a scene graph. So we have a stage where we'll be drawing on, and the stage has a scene graph. And since we have a scene, the scene also has content. The content here in this case is a widget called image view. The sole purpose in life is to draw images. And if you ever try to draw an image using the Java toolkit and all that stuff, you know that you need to wait for the image to load, and so you need to have some sort of listener and consumer and all that stuff. Image view handles that for you. And we have an advantage with that, which I will show you a little bit later, because image view will actually handle all that for you. So image view will have an image, which is an image object, which is a plain old Java object, a POJO, containing just image data. And in this case, we'll load the image from a URL, which is something, a PNG file. So this is all the code that's needed. That was exactly what I wrote, actually. All the code that's needed in order to show this image. Right? But, of course, there's some stuff like that, because we want to do this. We want this to look sort of like a PowerPoint PowerPoint presentation, right? So we need to get rid of the bar, the menu decoration, and the window decoration and stuff. So let's do that. There we go. We still have the menu bar, which is a weird artifact of this preview that I'm using for on the Mac OS X. I've asked engineering about it, and they still haven't fixed it, unfortunately. But it will be fixed. But as you can see, we now have something that is actually full screen on decorated window, and we're doing stuff. Oh, sorry. Need to switch slides as well. there you go. This used to be, when I first wrote this presentation, this used to be something that was really, really hard. Now in the latest version it's not, so it's really no point lingering about this particular change. Apart from one thing. As you can see, we're now filling up the stage object with, can you see this pointer? Maybe. We're now filling up the stage object by setting attributes on it. This is actually just being compiled into state, set full screen or something like that to true. But in the JavaFX script language, this is how we handle invocation of objects. We declare that we have a stage, we set a few attributes on it, like full screen equals true, scene equals scene, and so forth, and that's how we do it. And we will see more with that as we go through this presentation. So we're setting all the properties that we have on our objects. All right. So enough of this sort of recompiling to change slides. Let's enable us to actually switch slides using, for instance, key presses. And in order to do that, the first thing we need to do is get ourselves a list of images. Ooh. Right, there we go. Right, so we have several pages on our presentation, and I've actually started to look at something of it. So what did I do here? Well, first of all, I created a list of image objects, and I used two kinds of list comprehensions that are also an integral part of the JavaFX script language. The first one is this expression, which just creates a list of integers 1 to 63. Well, not 63 this time, but never mind. I just create that list. So it's exactly the same as list comprehensions. For instance, well, you have the same in Haskell. How many of you tried Haskell? Here you are, then you recognize it. Yeah, the Python is, well, why can't you get a range? It's different. Yeah.
You can create a list like this.
You can, but it's still a range, so it's weird. But there you go. And then the second type of list comprehension is the for loop in this case, which does exactly the same thing. Well, it does exactly what you think it will. It loops through every element in that list, and for every element, it invokes an image object or creates an image object using exactly the same expression that we had before. Apart from that, we have a string substitution here, which says that format the variable I, or the value in the variable I, as the 3-digit integer. So it's 001, 002, and so forth, which creates a couple of URLs and then loads it into an image, into an array, or into a list. So that's the first thing. Then we have an index variable that will enable us to point into that list. And then here's the stuff. Well, then we have unknown key praise function. We increase this index variable every time we press a key. And here's the stuff. We bind the value of the image in the image view to this expression, which is the image pointed to by, or indicated by, the index variable. And the data binding facility in JavaFX script works like that every time this expression changes, this attribute on this object gets updated. And since the image views object is responsible for having a listener and listening to whatever this attribute says, that is, the change of the image object, and also when the image object is fully loaded and all that stuff, that means that whenever we change this expression, which changes value, image view will actually redraw it. And the data binding facility is one of the massively useful things in JavaFX. Because if you've ever done GUI programming, you know that one of the things that you'll end up having is enormous amount of listeners. Right? Because you will have a listener for instance, someone pressed that button, someone changed that value, someone changed that value, and so forth. Because if you have the model view controller pattern, you'll have exactly that problem. Something changes in the model, and the controller needs to understand that and update the view, so saying that, well, you redraw yourself kind of thing. And this binding facility does that automatically. And the binding facility can only be used for stuff like updating graphical elements on the screen or on the view. It can actually be used for anything. So anything, any value, any property in a JavaFX object can be bound to a value, which means that the value of that property will be updated whenever the expression changes. And that can be any expression, including function calls and everything. And JavaFX script will actually, the runtime will actually take care of that and see that if you have a function call, Martin? Oh yeah, here's one. So if you have a bind something, right, never mind that then. If you have a foo colon bind bar function which have three arguments, A, B, and C, if any of them changes, if any of the argument changes value, the runtime engine will notice that and update the foo attribute on whatever you have. Ah, thank you. And this is a whiteboard marker, not clever one. Thank you. So if you have something like this, anytime any of these arguments changes value, the bar function will actually be called and the foo attribute will be updated. But only when this argument changes. Otherwise it won't be called. That's pretty useful. Right. So, yeah. So are you with me on this? Yeah? right? So just one thing left, and presentations should have cool transition effects. So I'll give you a cool transition. Well,